All right, and we're back. It is COMP123 in the summer 2016 semester, and it's week 6, part 2 of our broadcast. We just finished describing our business rules for this little game in my mind that I'm making. The ability for us to move my player around and do stuff. My player can score, and my enemy can't, but he can flee and seek, and my player can't. Right? Those are the kind of things that he can do. So flee and seek is kind of AI-like behavior, right? Because an enemy can flee and seek. What other things can an enemy do typically that you can see in other games? One of them, I'll put it out there, another piece of AI, they patrol, right? They patrol. They kind of go back and forth and they look around, see if there's anyone around. If they see the player there, then they seek the player. If the player is too tough and he beats them up, then they flee. Enemy behavior, right? Some enemies are so tough they never flee, right? Let's put this down. So we'll say another method that the enemy has is the patrol behavior, right? So enemies are more actually complex, if you will, than players are, because players we control, enemies the computer control, right? I'm putting it as part of the abstract abstract superclass of enemy, not shooting enemy or touching enemy, because shooting enemy and touching enemies can do both the same thing. They can still patrol, they can still flee, they can still seek. Okay, those things. The other thing that enemies have that players don't have is morale. Okay? Some enemies, when you hit them one time, they run away. Other enemies, they stick around, right? And not all enemies have morale. Like, the different enemies have different levels of morale, right? Morale means the ability for them not to be afraid, you know? And you can program that. So it's not a behavior, it's a property. So what's my morale level? If the enemy's morale level is fairly high, then he'll keep fighting me until he dies anyway, right? Some enemies' morale is low, and if you hit him once, he'll run away, right? You know, that kind of thing. Because maybe they only have one life, right? That kind of thing. So let's go back there, and we'll add a property to the enemy called morale. That's what it's called. So a couple of other things we added in here. So flee, patrol, and seek. We also have morale, and we have score. We're starting to define, our player and enemy objects. Now, we haven't defined things like the arena where the player and the enemy play, all right? Those things are not within our program right now, right? All we're defining is just our player and the enemy and what they can do, right? Capabilities. All right, let's talk about the interfaces. I want to start talking about interfaces first because my eye-shootable interface, right, and my eye-touchable interface, it really depends on, not all enemies and players are eye-shootable or eye-touchable. Therefore, I can't put them on my superclass, my abstract class game object. If they all were eye-shootable or eye-touchable, then I would put it here, right? But my player class definitely has both, and so does this one, my shooting enemy. Shooting enemy and my player are very similar, right? But my player has a score property, and my shooting enemy does not, right? Shooting enemy also has, all these things that my player doesn't have. So again, if you look at it, shooting enemy is the most complex object in the game because it can shoot, it can touch, right? It has morale, flee, patrol, and seek behaviors, right? And it has the most capability of the game. All right. So far we've talked about these things. How about we've talked about lives, names, speed, and strength. How about defense? I think that's a great property too. So maybe I have a defensive property as well. So player might have body armor or something like that. That's defense. Enemies might have body armor. That's defense, like armor, right? So add defense as a game object property, not as a player or enemy property, because both player and enemies can have it, right? So right click. I'm going to add a new property called defense. And on that, when I look at defense and strength, right? Defense and strength. Now I'm going to make a change. Now as I'm composing in my mind how my game object is going to be, right? My generic game object, I got to think about this. Do I mean attack strength? Is that what I mean? Attack strength? And what's the difference between attack and attack strength? I know my defense. My defense is how many, how much I can defend. Or is it? Or does it mean the ability for me to avoid attacks? There's different kinds of defenses. There's active defenses and passive defenses, right? I'm being complex here because I want to be complex for this example, not because I want to make you crazy, right? Here's active defense. Active defense means If I'm a player, I'm going to dodge, right? So the actual bullet doesn't hit me. That's active defense. Passive defense is when I get hit by a bullet, and I have body armor that stops the bullet from going through. That's passive defense. So there's two types of defenses: active defense and passive defense. Here's a question: do all enemies and players have both active and passive defense capabilities? Right? You could argue that they all do, right? Or you could break it up into more interfaces. Some of them that have, and some of them that don't. A shooting enemy that has passive and active defenses, right, would be the most complex. In our game, just to make it easy, we can rename our defense, and there's also active, there's attack, there's the ability for me to attack, right? The ability for me to attack, and then how much damage I do. So attack capability, you know, my fighting ability, if you will. I don't know, the ability for me to shoot, the ability for me to hit, right? And then how much damage I do because of my strength, how strong I am, right? So it really depends if you want to get really complex. In some games, if you play a tabletop game like, I don't know, I'm going to go back now to the Marvel superhero games, you actually go back to role-playing right now. When you sit there and you go, I have a fighting is a score, right? So fighting allows me to hit in combat, melee combat, like hand-to-hand, right? Boxing, fighting, right? Then there's agility, which tells me how I'm able to aim and shoot. That's two different abilities, right? Then I might have a strength. So in fighting combat, I hit a guy. But if I have some kind of power, right, my power will generate how much damage I do after I hit with my agility. Or if I shoot with a gun, right? The gun is the damage, not me. My item, I can carry items that have that can do damage, right? So again, depending on how complex we want to make the game, right? For now, for our game, let's just give it like an attack and defense value. All right. So let's just say let's change strength to attack. That's my recommendation. So we'll just rename this. So if I just double click on here, I can just change strength to attack, and I have defense. Why? Yes. Oh, I like how you're thinking. Tell me. I want to bite into this, man. Go. Yeah. Yeah. Chance to hit, right? Yeah. That would be like a fighting. But that's chance to hit hand to hand, right? What about chance to hit shooting or ranged, you know, with my abilities, or with my you know, some kind of intelligence attack? Yeah. Accuracy. That's right. Accuracy. That's more. I like that. Maybe that word captures it more. See what I'm saying? What are we doing? I know we're playing, right? But this is how we learn, guys. We're playing. We're creating the mechanic for my game, right? This game we're kind of creating off the cuff. We're just brainstorming here, right? But that's how we code, man. That's how we code. We sit there and go, what business rule can I use? How do I map the real world into what I'm doing here? And how much of it do I want to map? When I go back to when I talk about playing games, okay, one of the things we have to always think about is this, and I always tell this all people who make any kind of game ever, right? It's realism versus playability, right? So if I make an ultra realistic game, it's going to be very little play. It's not going to be playable. I'll tell you right now. Think about the most difficult games that are out there today, right? What's the most difficult? One of the most difficult games? Like it's a killer game that you play. What's that? Okay. What else? Online, right? No, but there's a bunch of other ones, right? Like they're crazy. You can't win them. You can't beat them again. There's easy games that is really, really playable, and then you can kind of move up, right? You know, the ranks, right? But there's some games that are unplayable. They're so realistic, super realistic games. Taken, you know, and I used to play these kind of games in the tabletop format, right? Where it takes you for one turn, it takes you an hour. Super realistic, not so playable, right? That means for a couple of hours. What was that? Shadowrun, yeah. There's other games like that too, like really, really hard games to play, but takes a lot of detail, lots of work, lots of brain power just to do one turn. How about easier games? So there's a game that used to be called Supremacy out there. I want you to look it up one day. It's a tabletop game. It's you know these powers, right? So I play like a country, and I can take care of resources and do all kinds of stuff. I can harvest resources. I can send my armies. It's almost like a super duper Risk game, right? Risk, I can do a turn in probably like 10 minutes, right? This game, one turn for me took an hour, right? Super realistic, not so playable. So playability really suffered, but realism was there, right? We got to find that game balance, is what it's called, right? When we make games, if we're ever going to make games together, between realism and playability. So here we have to sit there and say, because we're brainstorming, do I really want to go to nitty-gritty and say attack strength, defense strength, passive attack, passive defense, active attack, and then go really into the nitty-gritty about my character, each game object's attributes, if you will. Like, do they all have fighting, agility, strength, endurance, reason, intuition, some kind of psyche, so they can reduce, resist psychic attacks? How difficult to get it? You can go as complex as you want, but then it becomes more realistic and less playable. For us, this is enough. All right, let's get to programming now. We've talked enough, right? We planned enough, and we can do. Some of the people that like to plan too much, they're into this thing called analysis paralysis. We plan, but we never do anything. We're not men of action or people of action. We're just analyzers and observers. All right, so let's double click on my game object to fix this up. So here's my game object. We need to implement some of this stuff, right? So the one things we need to implement is things like, I've got my game object constructor. My game object constructor, what do I want to do with it? I want to actually take in the name of my game, right? I need a few instance variables though, and I can do it in two ways. I can do it here, right, inside the actual code, or I can go back to here and I can create some instance variables here that I can recode later, which might be easier. So I'm going to go right-click. I'm going to add in some fields, right? One of them is going to be called, attack. And I'm going to kind of redo all the fields again. So just use the same thing as the fields. Defense. Notice that I'm putting them underscores so I can set myself up for it to work properly. Attack, defense, lives. Makes sense, right? And then some fields. Name. Name, lowercase. And let's do another one. Add a field in here called speed. So we got some stuff, speed. These don't change, but these definitely have to be there. And what I want to do is I want to double click on my game object constructor here, right in the diagram. And what it's going to do is it's going to take me right to my game object. And what I want to do here is I want to define some of this stuff. So is my attack a number? Yes. Is my defense a number? Yes. Is my lives a number? Yes. Integers are good, right? Is my name a number? No. So this is going to be string, right? Is my speed a number? Yes. Okay, question. My attack, my defense, my lives, and my speed, are any of these, decimal numbers or floating point numbers? Do we want to get that specific? We can. Like, for example, I could have an attack of 32.5, as opposed to 32. Is it going to matter in our case? The answer is going to be no for us for today. Okay, we're going to keep it easy. But we can make these decimals instead of integers. For now, integers are just fine. Let's just deal with this is complex enough example as it is. Put it that way. All right, so here's our game object. I want to take in the string, which is our name. And what I want to do is inside my constructor, let's get rid of this. I want to use my name property to set my string, my name, right? So I need my getter and my setter set up. So I'm going to return this dot underscore name. And it says cannot implicitly convert type string to int. Oh yeah, because all these are ints, right? And I want to set this. So I'm going to say this dot underscore name is equal to the value. So that I set that up, the name value, the name property here. I'm just doing this just in time. Nick, I'll be right with you. And I can do something like this. This dot name, capital N, is equal to name. These are all things we've done before. Nothing different here, right? So I've set the name of my value to this, right? Well, if that's true, I got to be able to set my lives and everything else, which means I need an initializer function to set my lives up and everything else the first time for all game objects. Some kind of initializer function that I can call, right? And I got to be able to set those things somehow in my initializer function. So got to figure that out too. All right. So let's keep going. So lives. So this dot underscore lives is what I'm going to return, right? So I'm going to return this. That's let's just do them for all those. Let's fix all these functions up, right? And this dot underscore lives is equal to value. Actually, we're just making the generic ones. That's what we're doing here, but let's just do them anyway for practice. So I'm going to say return this dot underscore speed, right? And this, I'm going to set this dot underscore speed is equal to value. Attack. You can see all these ones. These are all like these are all properties, right? So return this dot underscore attack and return, or sorry, this dot underscore attack is equal to value. And again, I could set all this stuff up to happen automatically, but what the hell? Might as well practice. Return this dot underscore defense and this dot underscore defense is equal to value. So there you go. I've done all my methods. For moving right, moving left, let's just put a console command for all these. It says moving left. So the name of the person is moving left. That's what I want to put in there, whatever the name of the enemy or the player is. So I'll say something like this. Console log or console write line, right? We'll say the name of the player, so we're using string interpolation here, right, is moving left. Moving right, sorry. Moving right. Right? And the name of the player is going to be this dot name. Right? And you know what? I'm going to copy this thing, and we're just going to copy that. We're going to change this from moving left to right and so on, just to save time. So moving left. One day when it updates. You can see what I'm doing here. I'm just creating that basics for my stubs. I'm going further and actually starting to program each one of these things. I want you to think of each of these methods as a little paragraph that I'm writing in my book. All right. I've outlined what I want to do with my story, and now I'm gonna, I'm gonna flesh out the details. Right. This is how I like to code. I like to outline first, and then I flesh out the details. Right. I implement all the methods first. You can also do the testing from a testing perspective as well. Moving forward, I like it a lot. Moving back, right? Turning left. This is turning left. And this one is turning right. So we got, that's what this my player can actually do stuff for, and I fixed it for it to work. Turning right, whatever the player is called. Okay, so we've all these things are done. I'm not going to do the comments today. I'll do that later on. Maybe we'll do it on next day when we get together, right? But more or less, what we've got is we've got one constructor, and we've got a bunch of properties and methods, and then I'll do much. Let's close this off for now. Let's go back to the enemy. Or actually, let's do because the enemy is a subclass, but it's also an abstract class. Okay, here's a problem. I've got this underscore. Why do I got this underscore in here? Because I've got a new constructor, right, for the enemy that I haven't implemented because my game object has a constructor that takes one property name. I must have this in here. And if you notice, it says that. It says there is no argument given that corresponds to the required formal parameter name of game object string. Like it's listening for a constructor that I don't have, right? So let's make the constructor here in the diagram. So in my enemy, I'm going to make a new constructor, right? Here's what's called enemy. And if I double click on my enemy constructor, it's going to take me there. And what I want to do with the constructor is I want to listen for a name, so string name. And what I want to do is I want to return to the calling class, to my base class constructor, I want to return the name. So whatever name I get, I want to return, and that takes away the error that I get from my enemy. That's what it's listening for, really, at the end of the day. Oops. And what I want to do here in my enemy constructor is maybe add some other things. Remember, because my enemy has other stuff in here. But I can leave this as the empty constructor right now. Why? Because my enemy constructor doesn't really do anything yet. It will, but not yet, right? Morale is a property, and so is and seek, flee, and patrol are methods. Let's go back to my thing here and add some a private instance variable for morale. So right click, I'm going to add a field that we're going to call underscore morale. Right, there we go. That's a field. And I'm going to go back into my morale property, right? Notice that it makes fields private by default, which saves us a lot of time. All the typing, the syntax, all that stuff's taken care of for us, right? And here's our public morale. And what we're going to do is we're going to say something like this: return this dot underscore morale. It's going to return the morale score. And then think about morale as how brave the enemy is. Is he going to run away right away when he gets hit, or is he going to keep fighting? This dot morale is equal to value. Okay. Seeking behavior is, again, it's some kind of thing that's happening. So we're going to say console write line, whatever the enemy is seeking. That's what he's doing. We're going to take this, copy it, and put it here for fleeing. Trolling. There's one thing we're missing, eh? Which one are we missing? Patrolling. How about fighting? Can we do fighting here? Should we do fighting here? I think the answer is no. I'll tell you why in a second. Well, yes and no, but we're going to talk about this in a second. Okay, going back to our interface for a second. This is trolling, fleeing, and seeking. If you go to our interface, both of these have touchable into them, right? So now I'm going to refactor. Why would I refactor? Look, I have touchable in both shooting enemy and touching enemy, right? Because both can touch. Where should touchable be? Here, right? Because that means both of them will inherit those things, as opposed to putting it here. Why would I do that, right? If that's true, I could, if I wanted to. There's one way I could do it. I'm just trying to think about this in a sense. Do I want to construct an enemy that's just enemy, right? Like, do I ever want to create that from an abstract to make it a concrete class? And the answer is right now, no. I might want to keep touchable separate like this, only because, you know what, there could be business rules around it, right? Like, but typically what I would want to do is try and take those two touchable interfaces and put them onto this. But if I was to do that, that means that a generic enemy can fight. So that's one thing that's missing. I have flee, patrol, seek, and fight. I don't have fight here. I could put fight here and here, right? Because it's part of the touchable interface, right? So that's what I'm going to do. I'm going to leave it as is for now. It's just a design choice. My design choice is going to be leaving fighting outside of my generic enemy, right? Because some do and some don't. Maybe different kinds of fighting that I want to do later on. All right, I've done my enemy. It's implemented. I don't want to do these yet before I do these, right? Because I don't want to do my player yet either. Because my player has shootable and stuff like this. He's got a score. Well, maybe I do want to do one more thing with my player. I want to add in a field called score. Let's set up my property for my player, right? So my player has a property. Right now, I don't have any kind of custom constructor, but I definitely want to do this dot underscore score. That's what I want to return. This dot underscore score. And I definitely want to set this dot underscore score is equal to value. So I want to fix that with my player, because those are the things that all players do. I'm getting an error, right? I got my I shootable and I touchable. I haven't really defined what those are, but this has something else to do with it. I'm listening for my constructor, which is taking in the name of the player, which I haven't done here. So I need to create my constructor. Let's do it at the document level, the diagram level. So I'm going to right click here. I'm going to new constructor for my player, which we're going to call player. All right. Let's check this out. Let's write the constructor method. The constructor method then must take a string that's a name and return that name back to the base class, base constructor. All right. For now, it doesn't do anything, right? But we're gonna leave it like this. Must take a name. And my player is pretty much done, right? Again, we're going to continue constructing this stuff next day, so don't despair if it seems like we haven't done anything yet. Let's build our interfaces, and then we're done for the day. All right. Okay. This is the new stuff we haven't done before. Remember that we're going to declare methods inside these interfaces. And for let's do the touchable one first. Here's one for the touchable one. So here's my public interface touchable, right? Okay. Let's go back out to here. I'm going to add, and look at the things I can add in my touchable. A property, an event, or a method. I want to add a method. And my method that I'm going to add into my touchable is fight. And my method that I want to add to my shootable is shoot. It's pretty easy, right? Shoot. Okay, so fight and shoot. Notice that they're italicized, these properties, these methods. Why? If I double click on my touchable, it says void fight, right? It's not public or private, it just says void fight. And the reason why it does this is because automatically when we declare a method, the method header inside of my interface, right? It's automatically abstract. They must be overridden. Now I've messed up my other stuff. An example of this would be because my shooting enemy and my touching enemy and my player both inherit from touchable and shootable, I have to implement the fight and shoot methods in those things. So let me take over my player to give you that example. My player now has two errors, right? Under the shootable and touchable, it says, under shootable, player does not implement interface member iShootable shoot. And the way to do that, of course, would be to implement those methods. So let's do that. So I'm going to go back to my diagram, go to my player, and I'm going to add a new method. Here's my new method. What am I going to call it? Shoot. Right? Add a new method. I'm going to call this thing fight. Right? Let's go and check on my player diagram and see what I need. Right? Well, I kind of got it. I think my touchable and shootable are okay now. Right? There's no errors anymore. And if I go down into these two methods, you can see that it's public void shoot. But what I really want to do is public override the shoot method, right? That's what you would probably think you should do. Public override void shoot. But it says that no suitable method found to override. Why? Because it's an interface. It's not an abstract class. It's not an abstract method that's been passed down from an abstract class. It's an interface. And all I have to do is define it. I don't have to override it because it doesn't exist. I'm actually defining it here. All right? So in my shoot method, right, I want to say something is the player is shooting, right? So let's say the same thing actually that we did before. See if I can do this. Player name is shooting, right? Player name is fighting. For now, those are just little stubs, and we can kind of go in there a little bit more, right? So shooting and fighting, and then the same thing goes with my diagram. I'm still not complete. My shooting enemy has both shooting and fighting as well, right? Because look, my shooting enemy has all kinds of problems. It needs a constructor. It needs the method for shoot and fight. Those are the three things it needs. Let's go back there and do that. So here's my three methods. Add the constructor. Add a method for shoot. Add a method for fight. We're just penning them in, guys and girls. And this one here, all it needs is fight and a constructor. Add a constructor. Add a method for fight. You can see how this is coming together now, all right? And let's define the fighting and shooting methods, and then we'll go for the day, right? So here's my fight method, right? Here's my shooting enemy. My shooting enemy's constructor needs a name, which is of type string. That's what it needs. I know this is a lot of repetition, but you see what I'm getting at now. It's going to return this to the base class, which is name. So we fix that one. There's different errors we got to fix, right? And this one is fighting and is shooting, right? So whatever it is shooting, and whatever it is, this enemy is fighting, right? Those are things that it does with fighting and shooting. And now I got to do the touching enemy, and we're done. Touching enemy, right? And he's taking a name, string. That's a name. Passes it back to the base constructor. And we're not going to put anything on it right now. And in fighting, all it can do is fight, but it doesn't have to shoot because it's not part of the iShootable. It doesn't implement the iShootable interface, right? Shooting, fighting. Now we've completed everything. We can save our class diagram. Okay, here's what I want to do now before we go. See this little button? There's two buttons here on the top. One of them is this, gives us the types, and one of them is this that gives us the full signature. I want to turn the full signature on everything. Let's see if this works. I'm going to highlight everything here by just dragging the whole diagram, right? And I'm going to click this little button here that expands everything so I can see all the details. And give me my space there. Okay. So that's more of a diagram. Now, if I was gonna give you this in an assignment, would you understand what I'm doing? Would you understand what I need? Right? That's what I'm talking about. If you're gonna get handed this, you understand what all the methods and properties and fields are, right? Guys and girls, you're gonna get this for your test. I'm gonna give you this whole diagram, and I'm gonna say, go. What do I expect you to do? In 10 minutes, you can set up your structure for your all the things you need, and then you can spend the time kind of making it go, right? All right, I think that's enough for today. I think parting thoughts for you guys: abstract classes are not concrete classes. We don't create objects from those classes. Interfaces further define methods we must use inside of our classes, right? To give us a different shape and to define different business rules between one kind of class and another. Okay? Thank you so much. We'll see you next day. Remember that Friday, we have a quick quiz, 10 minutes, based on last week and this week. I will. Thank you.